Hello! In this video we're going to actually look at some trigonometric equations. I'm going to give you these four examples, and they will probably be ones that you will struggle with in your homework. And they go over a lot of some of the things we've covered in class and some things we maybe haven't covered so recently in class. I would strongly suggest that you put your unit circle sheet in front of you, because I am not going to have that displayed on this screen. But at the end of each of these problems, we will probably be looking up when certain trigonometric values actually match where they are on the unit circle between 0 and 2 pi. So without further ado, let's begin. So, the first problem. Let's look at this example. We'll call this example 1. And we're going to look at 2 cosine squared theta plus cosine theta equals 0. Okay, so the first thing we should do is we should let u equals cosine theta. What this will do is it will allow us to actually look at this equation in a more simpler light, something that we can think about in an algebraic sense. So 2u squared plus cosine u, which is now, whoops, let me erase that. U equals 0. So, now what we have is 2u squared plus u equals 0. So the next thing we should do is factor this. Since we have to solve what u is equal to, if we factor out a u, this will give us a monomial and a binomial. Factoring out a u from the 2u squared is 2u, plus factoring out a u from u would just be 1, and that's equal to 0. Okay, so what we do now is we know that since u times 2u plus 1 is equal to 0, that means either u is equal to 0 or 2u plus 1 is equal to 0. Okay, so what that now gives us is it gives us one answer, that either u is equal to 0 or this is equal to 0, which we can solve by using inverse operations. We can subtract 1 from both sides. This makes 0, so 2u is equal to negative 1. And then we divide both sides by 2. Oops. And this gives me 1 over here, so u equals negative 1. Half. Now, we learned before that u was equal to cosine theta. So now that we know that either u is equal to 0 or u is equal to 1/2, now we can say, okay, well, cosine theta is going to be equal to 0, or cosine theta is equal to negative 1/2. You can see that down there that I'm just substituting back the cosine theta into each instance of u. So if I look on the unit circle, I can see that cosine theta equals u at 2 moments. Pi over 2, or 90 degrees. Pi over 2 is when we have one of those situations when cosine theta is equal to 0. Also, at 3 pi over 2 is another moment when cosine theta is equal to 0, or at the 90 degree angle and the 270 degree angle. Now, when does cosine theta equals negative 1/2? Looking at our unit circle, we can see that's 2 pi over 3, and also at 4 pi over 3. If we've done our unit circle correctly, these values of cosine will be negative 1/2. So our answer set is all 4 of these answers. Since we have no redundancies, we can put them from lowest to highest. So we're going to start off with pi over 2. Then we're going to move to 2 pi over 3. Then we move on to 4 pi over 3. And then finally at 3 pi over 2. And this gives us our first example here with the solution set, and the techniques we used were substitution and a little bit of factoring, and then some algebra to solve for x, or in this case, theta. Okay, so now what we're going to do is look at another example. And let's get our pen back here, change colors just to be a little fun. Okay, so this problem starts off with, this is the second example here. This is tangent, so I'll just put EX2. This is tangent theta minus 1. And we're going to multiply that by secant theta minus 1 and set that equal to 0. There we go. Now, the more you actually know about mathematics is probably going to get you into trouble here, because your brain might be impulsively thinking, well, let's FOIL this. Well, foiling is going to make this rather difficult because you're now going to have combinations of tangent and secant among 4 terms. Now you might think to yourself, well, if I turn everything into sine or cosine like I do in the trig identities unit, maybe that'll make things easier. Unfortunately, it won't. Because by foiling after you turn everything into sine or cosine, it's going to make things pretty ugly. Alright, well maybe there's a trigonometric identity that can help us here. And unfortunately, no. You can't actually use trigonometric identities because those are generally with, and these trigonometric identities I'm thinking of are the Pythagorean identities, which usually have compositions of tangent squared and secant squared thetas. So, what are you going to do? Actually, what's nice about this problem is since it's already factored into 2 binomials, we can say that tangent theta minus 1 equals 0, or secant theta minus 1 equals 0. So what this allows us to say is that, oh wow, so I can just solve for theta here? Yeah, and there's actually going to be no reason for substitution since we have a unit circle sheet in front of us. So if I just add 1 to both sides here, I'm going to get tangent theta equals 1. And when does tangent theta equal 1? Well, that equals at pi over 4, also at 5 pi over 4. If you look at your unit circle table correctly, these values along the radian side, or degrees if you're looking at degrees, these will be equal to 1. How about this? Well, let's add 1 to both sides. Secant theta equals 1. And so if we look at that, secant theta equals 1, and we can see that that only happens when we have an answer at 0. That's when secant theta is equal to 1 at 0 degrees, or 0 radians. So the answer for this problem is going to be at 0, pi over 4, and also 5 pi over 4. So there's example number 2. I'm going to do 2 more examples here. Let's see here. Let's go to another tricky problem. Change to a new color. And write down this is example 3. This is going to be one of my longer examples, so I'm going to try to write a little bit smaller this time so I can fit it all on this one page. So you might see me working on the left-hand side, then working on the right-hand side and continuing the problem. Okay, so in this case we have the sine squared theta. We have minus cosine squared theta equal to 1 plus cosine theta. What's nice about this problem is that you might have started a little bit of the trigonometric identities unit, and from that you know that there are certain formulas that we can use to convert sine into cosine as long as we have squared properties, and we do. In fact, this sine squared theta is equivalent to some form of cosine squared if we remember the formula correctly. A very common mistake I see is many people go like, oh, sine squared theta plus cosine squared theta is equal to 1, but it actually isn't. That sine squared theta plus cosine squared theta is equal to 1. And you might say, well, if I just divide everything by -1, that would turn it into a plus, but the sign would actually become negative and you'd be in the same problem. So the only way to actually get out of this problem easily is to convert this sine squared theta into 1 minus cosine squared theta. And I would refer to you to go to your properties sheet that I may have handed out in class, or go to any trigonometry book and you'll find in the trigonometric identities section that sine squared theta is equal to 1 minus cosine squared theta because of the original property that sine squared theta plus cosine squared theta is equal to 1. Alright, so there's my justification of writing down this step to this step. Now everything else just drops down. And let's keep on simplifying. Now what I'm going to do on the left-hand side here, I'm going to actually combine the cosine squareds, and if I lose cosine squared theta and lose another 1 cosine squared theta, now I have lost 2 cosine squared theta. And I'm going to set that equal to 1 plus cosine theta. If you are actually teaching this course and students struggle with this concept, what you may want to do is use the substitution step a little earlier than I do and turn this into 1 minus u squared plus 1 or is equal to 1 plus u. Students are going to have a much easier time moving around letters than they do actual trigonometric terms. I don't know, it's just maybe some kind of brain little confusion there sometimes when we get there. Alright, so let's go to see what we do next. Well, we should try to get everything to one side of the equal sign. We can move everything to the left or move everything to the right. A powerful factoring technique is to try to move your highest power over to where it's positive. That way we don't have to divide everything by -1. It'll make for easier factoring. So I'm going to add the 2 cosine squared theta to the left side and to the right side. 2 cosine squared theta. I'm also going to subtract 1 from both sides, and what this is going to allow is this entire thing on the left hand side is going to simplify to 0. And on the right hand side, what's going to be left now is basically these two terms, because the 1's simplify to 0. So now I have 2 cosine squared theta, and I have cosine theta. And what's great about this is they're both positive. Since they're both positive, I can commute them very easily without having to worry about subtractions or negatives or anything like that. So here's what I have now. 2 cosine squared theta plus cosine theta is equal to 0. I'm going to let u equal to, come on, cosine theta. Okay, so here's what I have. 0 is equal to 2u squared plus u, like so. Then I'm going to factor out a u, because I'm trying to solve for u, and with a power, this is the technique we will use here from college algebra. There we go. So 2u plus 1, and now what we get to do is we get to say that u, since this times this is going to be equal to 0, therefore u is going to be 0, or 2u plus 1 is equal to 0. Okay, well, now that we understand that, we learned that u is equal to cosine theta, so cosine theta is equal to 0, or 2 cosine theta plus 1 is equal to 0. Now I'm going to take all of these and move them up here to the top. So I've got my cosine theta equals 0. And now I have 2 cosine theta plus 1 equals 0. And I substituted that back in pretty early because from previous problems in the work we've done, we can subtract the 1 from both sides. So 2 cosine theta is equal to -1. And we can divide everything by 2. And then cosine theta equals -1/2. Come on, there we go. So now we're going to look at our unit circle and find out when all of this happens. Getting my notes out here. Looks like cosine theta equals 0 at pi over 2. Also at 3 pi over 2. And if we look at cosine theta equals -1/2, that is going to be at 2 pi over 3, and also at 4 pi over 3. So now we have all 4 instances when this is true. And so therefore we are going to list from small to large. Pi over 2 is the first one, then 2 pi over 3 in the second quadrant, 4 pi over 3 in the third quadrant, and then finally we get to 3 pi over 2 in between the third and the fourth quadrant. Well, there it is, my longest example there, and it's time to now do the fourth example, which won't be as long, but I believe it's going to be trickier. So let's get back to my original color, and let's do our last and final example of this video. Example number 4. What happens when we have tangent squared theta equal to 3/2 secant theta? This is an important part of the problem. You're not going to have calculators for this, so there's not going to be any way that you'll want to or want to try to even convert that to a decimal like 1.5. So we're going to proceed in that fashion. Now, having had some experience with the trigonometric identities unit, you can convert the tangent squared theta into secant squared theta minus 1. And again, you can refer back to your trigonometric identity sheet that I gave you as a quick reference, or you can look in any trigonometry book and you can see all the Pythagorean identities have this relationship listed with tangents and secants and cosecants and cotangents, and of course the sine squared theta plus cosine squared theta equals 1. So please look that up if you doubt my ability or reasoning for this. This is still going to be equal to 3/2 secant theta. Now, the reason why we're doing this is because we're going to do some factoring, and I want everything in terms of secant, because when I do my substitution, I would like to see that substitution for one trigonometric function. So I'm just going to do that right now. Let's see, let u equal secant theta. Okay, so what we're going to do now is have u squared minus 1 equals 3/2 u. Well, what I should do is I should subtract 3/2 u from both sides. It's not my only way, it's not my only thing I could have done right here, but it is going to be how I set up my trinomial on the left-hand side for factoring. U squared minus 3/2 minus 1, and that's equal to 0. Now, one really good factoring technique, and we can use this factoring technique if we're in an equation. We can't actually use this technique if we don't have an equation, is we can actually get rid of this denominator of 2 by doubling both sides. You can double both sides of the equation by multiplying both sides by 2, which is true if we have an equation. If we did not have this equal sign, this would be an incomplete step. And if you're solving trigonometric identities without the equal sign, you can't actually do this. You can't double one side, without actually having another side to balance that equation. So here we have 2u squared minus 3, because 2 times 3/2 is 6/2, which reduces down to 3. U minus 2, because we doubled everything on this side, and doubling 0, of course, makes 0. So now we're going to actually factor this. And I'm going to factor this using a technique that I called the master product method. So we're going to take our first 2 and multiply it by our last -2, which gives me a -4. -4 has many different ways you can multiply to get to it. I can think of 4 ways. And the order does matter in this situation, but it won't matter once we put it into our problem. So here's the question that works for this master product method. What number multiplies to make -4, so 2 times -2, and adds to make -3? Now, the 2 correct answers would be some form of -4 and 1. Now, you could write that down as 1 and -4, or -4 and 1, because these two numbers do multiply to make a total of -4, and add to make a total of -3. So the order does matter when you actually put this into my next step, which I like to call the Atari step, because I make a little Atari symbol here, and I put my -4u here, and I put my 1u here. I normally don't like putting numbers in front of letters. It's not actually simplified, but I like to show that in the step to see that negative 4u plus 1u, which is what the middle part of the Atari symbol is supposed to look like here, that little plus symbol right there, that is how this gets put together. Now this isn't the only way to factor a trinomial, it's just the way that I like to factor a trinomial. So if you have other ways to factor your trinomial, whether you do it mentally or have area models, it works. But I like this method because now, even if I got the negative 1 here and the negative 4 here, this allows me to now group. So the grouping method is when we take the first two and the last two terms and see what can we factor out of both of those. So I'm going to kind of push this over here. So if I have the first two terms, I notice there's a 2 that can divide 2 and negative 4, and it's the same with u. This leaves me with u minus 2, or 1u minus 2. Now, if I look here, and I just have 1u minus 2, the only thing I can factor out of that is a 1. So I'm going to factor out of that with a plus 1, and this leaves me with a u minus 2. Okay, so now I have a match, so I have my u minus 2. I can then take what I have left behind, which is my 2u plus 1, and make that into a binomial. Now, what I just did to go from this step to this step is an actual distribution problem. Imagine if this was a and c, and this was to the term b and b, we actually can take our b multiplied by a plus c. Now, what I just said right there may have gone over your head a little bit, but it actually does work. If you consider this u minus 2 as just one thing, so if we call this maybe some, I really don't want to muddy this up, but maybe I can do some color coding, right? So imagine this and this right there being yellow. Now it's right here. And if I use some colors to show this is blue and this is purple. Now we have our purple and our blue there. So this is where this is actually allowable, because you can see that we've done, if I do yellow, blue, yellow, purple, that's the same as blue, yellow, and yellow, purple. So all this is to show that what I've done from this step to this step is fine. Now what I will do is I'm going to put this equal to 0 like I should have done up here. And then I can say, since yellow is equal to 0, now my u minus 2 has to be equal to 0. I notice that 2u plus 1 equals 0 as well. And now I can actually put my secant back in for that u. So now after I move things around, I'm going to have u equals positive 2, because I can add 2 to both sides, like so. And then I can just say secant. When does secant theta equal 2? And I'll look at my unit circle for that in just a moment. After I add 1 to both sides. And now I have 2u equals 1. Divide by 2. U equals 1/2. Which I know is now secant theta equals 1/2. Great, now I just get to look at my unit circle and find out when that happens. Now if I look at secant theta when that's equal to 2, thanks to my filled out unit circle, I have that to be pi over 3, and I have that also to be 5 pi over 3. Now if I look at my unit circle and try to find when secant theta equals 1/2, it doesn't. There's no situation when secant theta equals 1/2. You might be thinking of sine or cosine, but this is secant, so this actual answer doesn't work, and this ends up being my solution set. And those are the two times when my original tangent, if I go back to the very problem right here, if I plugged in the value at pi over 3 and I should probably put the fraction bar there. If I look at pi over 3 and 5 pi over 3 and square the tangent value, that is going to be when secant theta, if I multiply that by 3/2, that's when they would be exactly the same. And you can check that. You can actually visually check that and actually check the values out, that if you go to pi over 3 and square the tangent value, that would be equal to the secant value at pi over 3 once you multiply it by 1.5 or 3/2. Wow. Well, that was a lot of stuff in those 4 examples, but I think if you're going to run into trouble in this homework section, these are probably the 4 that you're going to struggle with. And I appreciate you guys sending me your questions, and I'll try to answer them. And thank you for watching this video.